So hi everyone, once again, welcome to the class for today, and we would be proceeding from where we stopped on Tuesday. So on Tuesday, we further went on to see what variables are. We further went on to see different types of data, that's data types. We went on to see the scalar, that's the singular type, the scalar type. And then we went on to see the dynamic data type. For the scalar, we spoke about the integers, the unsigned integers. We spoke about booleans. We spoke about other types of data like float too. Then we moved on to talking about vec and strings. Then from last class, I was able to explain the difference between string slice and a string. So today, we would continue from there. We would continue and look at, in fact, one of the most important, if not the most important parts of a programming language, functions. Every programming language out there, whether you talk of Python, JavaScript, Rust, talk of Solidity, talk of PHP, talk of Java, talk of C++, every programming language have what we call functions. Now, in different programming languages, they have different style of writing code. Some have what we call functional programming language. Then others prefer object-oriented. So some language allows, yes, it's possible to get the link to the record of the last session. Yes, it is possible. In fact, it is on the Notion page. Both the link and the slide is always posted on the Notion page. So as I was saying, there are different types of programming language, and some allow for both functional programming and object-oriented programming. Now, when we talk of functional programming, that's when you make use of functions so well. Then when you talk about object-oriented programming, in that case, you make use of what we call classes. But today, our focus will be on functions. We'll look at how to declare function, what a function is, and how to use a function. So a function is a block of code designed to perform a specific task. So if you declare a function, the aim of the function is it has a bunch of code inside it, and once that function is called, it is able to do what? To perform a particular task. So functions are used to perform different tasks when writing a code. Another purpose is for it improves code reusability and organization. What does this mean? This means that you can write a function and that function can be used in so many places. You can write a function that can serve as an helper function that can be used in other functions. You can also write major functions that are, in fact, the building block of your code. And writing functions basically does something. It organizes your code. I'm meant to make mention of something at the beginning of this class. Today's class will be divided into two because, as I made mention of in previous classes, right now I want, the class is now more of practical, and practical means you would have to practicalize it and do it yourself. Sometimes when you feel you have heard this thing and you feel you know it, the moment you start out to write out the code, you then notice that you actually don't know it. So the classes would be more of practice. And this practice means everyone have to write the code. And so in classes, you share your screen if you have a problem, and then we solve your problem for you together. So exercises will be given in class. And for those that cannot exactly get the exercises, you share your screen and everyone engage in looking at your code, and everyone can learn from it, and we all can solve the problems together. So back to functions. So as I made mention of, functions basically improve the reusability and organization of your code. So you can have different files, and inside these different files, you have different functions for different uses. So you can name some files helpers, you can name some files model, you can name some files based on whatever architecture or whatever application you want to build. Functions is basically what you use most times to do what? To call your code. In Rust, this is what a function looks like. You declare a function, you use the fn keyword. I heard a sound. Okay. So to declare a function, you use the fn keyword, then followed by the function name. This function name can be anything you want to name the function, followed by the parameter, followed by the return type. Then you have what we call the brackets, and then you have your code in it. That's curly braces. You have the curly braces, and then you have your bunch of code in it. Now, in this situation, we are going to talk about functions that have return types and function that does not have return type. This syntax I have just shown here is just a pictorial view of what a typical function in Rust look like. In other programming language, I think I've made mention of it before, function can be declared as function, in fact, spelled as F-U-N-C-T-I-O-N, function, and they declare it. That's what you use to declare the function. That's the keyword. In others, it can be func, but in Rust, it is fn to declare a function. Then you write the function name. Then inside these parentheses, if you have parameters, you can then pass in the parameters in it. Later on, we will see the difference between parameters and arguments. So as some developers actually do not know the difference between parameters and arguments. So we would see what parameters is and what arguments are as time goes on. So anatomy of a function. A function always have a name. The name is the identifier of the function. So that means that for every function you are creating, it must have a name. It could be a function that does an addition operation. In this example, the name of this function is add. And that's because it's a function that does an addition operation. Functions have parameters. Now, in this case, the parameter of the function is A and B. That's the input to the function. In other cases, the function does not necessarily need to have a parameter. It might be a function that just does some operations inside it, and then it returns something. Then it doesn't necessarily have to have a parameter. But for your functions to have parameters, that means you want to use these parameters as inputs inside the curly braces for the line of code you are writing. And in this case, for this function add, you have A and B. In this case, you are trying to add two numbers, A and B. And what the function does here is to perform the add operation, A and B. And so the function takes in the parameter, and then the parameter is used here. Another component of the function is the body. The body is the block of code. And the block of code is basically inside these two parentheses. So whenever you declare a function, you must start the function with your block of code must be inside these two parentheses. Did I just say parentheses? Inside these two curly braces, I mean. This bracket is parentheses, but this is curly braces. So it must be inside these two curly braces. Sorry for that mistake. Now, some functions have return type. Other functions do not have return type. I think I've made mention of this earlier. And in this case, the return type for this function is I32. So to declare a function that you want to return something, you declare it here. You make an arrow-like shape, and then you write the type to be returned. So in a case whereby you do not want to return anything, the function does not return anything, in that case, that particular function does not need you to write anything here. So in that particular case, that function is not returning anything. So now, moving on. Function parameters, inputs that a function takes, types by value, ownership is transferred, by reference, borrowing without ownership is transferred. What exactly does this mean? This means that whenever you declare a function like this as a value, in this particular case, the ownership of this parameter, whenever you are passing in the argument to the function, the ownership is transferred right into this function. And so in that case, the function becomes the owner of the argument passed in. Now, I know I've not spoken much about ownership, and in fact, ownership is a big one in the Rust language. Let me check the class if I'm okay, so I'm still with the class. Ownership is a big one in the Rust programming language, and in fact, that is a whole topic on its own. And I would not want to bore you with the idea of ownership right now, but I'm bringing it to your mind so that when we get to that particular point, you can reference back to what I've discussed. Other programming languages do not have this. Now, we have by reference. Now, an example of by reference is this. A parameter could be a whole value or by reference. An example of by reference is this. This is a string slice, and in this case, it is by reference. To reference a particular variable, this sign is used to reference a particular variable. Return types specifies the type of value a function returns. And as I've made mention of, for this function square, the return type for this function is I32. And what this function does is it multiplies the input, which is the parameter x by itself, and it literally returns the I32. Now, some questions might arise that in some other programming languages, whenever you are returning a value, you always have the return keyword here. How come there's no return keyword here? I believe that question should have come up. Another question could be, in other examples we are showing, and as I've made mention of during the last class, for us programming language, you are always ending every line with semicolon. How come in this case, there is no semicolon here? Or is it a mistake I made when I was doing this slide? So these are questions I would like to throw to the audience and hear what you think. Why do you think a semicolon is not here? Does anybody have an idea why there is no semicolon at the back of this line of code? X times X. Does anybody have an idea? Esteban? Okay, Coxie.
Sorry, I don't know what's wrong with myself, but I'm thinking maybe because the the return type is just like a value, I'm guessing. I'm not really too sure.
Thank you. Thank you. That's because it's a way to return in Rust. So if you are returning a particular variable in Rust, thank you, Coxie. If you are returning a particular variable in Rust, there are two ways of writing it. One way is for you to just write the variable without writing the return keyword and adding a semicolon. So if you want to return a variable in Rust, you don't have to write the return keyword and add a semicolon. immediately you write an expression like this, x times x, in this case without the semicolon. In Rust, it means you are returning the results here. Now, in some cases, you might now have your function have so much lines of code, and you in fact have some control flows. And inside these control flows, you want to return something. In that particular case, you would have to use the return keyword because you are trying to return in different situations. So some conditions, you are trying to return if some condition pass, do this. If another condition pass, do this. In that situation, you might need to use the return keyword. And that is exactly why this particular one does not have return. So if you add the return keyword there, that means we would have to put the semicolon. So thank you, Cogsy. Multiple return types. So a function can return a complex data type. The example we have here is a function returning a tuple. In this particular case, the function is returning not just one variable, but two. In this case, it is returning x and y. So it just passed in a function, and the function swap just does something. It swaps the value x here and the value y here, and it returns it. So one important thing you have to take note of is how Rust is a very, very typed language. So that means that even when you are declaring a variable, as I made mention of earlier in past classes, you add the variable type. Now, if you are creating a function, after writing the parameter, you include the variable type of the parameter in the front. In some cases, you don't have to add it there because the Rust compiler itself might detect that, okay, this variable type is an integer or it's a float. It's a floating value. But in most cases, you have to write the variable type. And that is exactly what applies in this case. In this particular function, you are returning a tuple. And a tuple, that means what you are returning here as a tuple must be the same thing as what you are returning here. This y and x. Imagine x variable type is a F64, float 64, and you return I32 here. There would be a compiler error. There would be a compiler error. Moving on. Now, the result type. Rust has an inbuilt way of how to handle errors. Now, if you are writing a very large code base, some situations might occur whereby you expect that function to return an error. So in this situation, this particular function, it only returns a variable. But then in certain cases, a function might need to return an error. How then do you handle returning an error? In that case, you use what we call a result enum. As we go on, I know I have not introduced some kind of data type that, for example, I have not introduced what a struct look like and how to use a struct. I've not introduced what an enum looks like. But this is a preview. You can create your own enum yourself because it's a data type. But there's an inbuilt enum type that is called the result enum. So the result type is used to return a function, is used in a function that returns either a variable or an error. So in this particular case, look at this function, this code. The function is a function that has to do with divide. Now it says it takes in parameter A and B. Now, the results, it is expecting either an I32 result or a string result. Now, in mathematics, when you divide a number by 0, what is it? It is undefined. And in fact, it's a math error because you can't divide a number by 0. Now, how then do you undo that if you are writing, imagine writing an application whereby you call this function and the parameter, the argument passed into this parameter is a 0. You have to undo that error. And in this case, you use the result enum. The result enum basically helps you undo the error. So in this case, it returns either an I32 or a string. Now, in some cases, this string could be an error. You could create your custom error type. But in this case, the error type that is being used is a string. So for the implementation of this divide function, it says if b is equal to 0, that is what you are dividing by. If it is equal to 0, return division by 0. So what does that mean? It will return an error. Else, return a divided by b. So whenever you are using a result type in your function, in that case, you need to wrap your result with an OK enum. So this is what you wrap your results with, an OK. So this is a very beautiful one Rust have done. As so many programming languages, you have to undo your error yourself. Talking about JavaScript, for JavaScript does not know when you are having an error because it doesn't even know what data type you are returning. It's not a typed language. But in this case, the compiler is able to know what you are returning, whether it is an error, and it is able to undo that error for you. And that is exactly what you see here. So to return an error for this other string one, you use the keyword ERR, and then you wrap it around this string. From last class, I explained how you declare a string variable. And you use either string from, or you create a string slice and use the helper function, the method dot to string. So that's exactly how you undo a result type. Now, using results in function, error handling, pattern matching with match or unwrap. Now, as we go on, match is a control flow that we will talk about. So in a situation whereby you need to use an if-else statement, but then for the if-else statement, like this example here, you do not want to use an if-else statement. You can use what we call a match. A match is basically used in a situation whereby you want to match different conditions with different situations. Now, in this particular scenario, what you are doing is you are calling this divide function. This particular divide function, you are calling it, then you are handling the error. In this case, whenever you call this divide function, you have to undo the error. How do you undo the error? All of these things are advanced things, and it is fine if you don't get it now because we are eventually going to see all of these things happen in code. So you undo the error. How do you undo it? By using a match, and then the match, you can either print the results. You see, this is how to create a match pattern. So the match, inside here is a variable you are comparing each of these matches with. And in this particular situation, divide is has a return type that is of result. And in that particular case, the result is either an OK value or an error. So you have to undo it. So where you are using this divide, imagine this divide is called, if the result was an OK result, you can print it. And if the result is an error, you can basically print it and handle it. In this situation, in this code example, the result is being printed and the error is also being printed. And we are going to see this as we move on. Normal return types. Common types, we have I32, F64, Boolean, strings. All of these are normal return types. So imagine this function is even with the parameter norm and it's returning a Boolean. So in this case, notice that the return keyword is not also used. It just says norm mod 2 is equal to 0. So if the value is 1 is not equated to 0, it returns false. If the value is 2 or it's an even number, equated to 0 is what is true. So in this particular case, that is a normal return type. So at this particular point, I want to pause to ask if there's anybody that have a question. Anyone that have questions at this particular point, based on what we have discussed up to this point. Is there anyone that has question? Okay, Emmanuel.
Okay, good evening. So,
Good evening.
when you were talking about, returning, not having to include the semicolon since you were excluding the return keyword, and that's,
Yes.
when you had, let's say, multiple instances in a function where you kind of like did, let's say, a couple of things that you would most likely have to use the return keyword, or you would most likely have to add the semicolon. So I wanted to ask, so in a situation where, let's say, we had a couple of things at the start, but then at the end, we had to return something. So if it's the end of the function and there's nothing coming after that, right? Is there still a need to include the semicolon there?
There's no need to include the semicolon. You can just return your variable, your value, or whatever data you are trying to return. You can just return it without adding. The point is, like other programming language whereby you have to specify return this value. You have to use the return keyword in other programming language. I'm saying in Rust, in a particular place whereby you want to return the variable, you necessarily do not need to use the return keyword to return. As long as you write that variable or you return that variable, because in some cases, the return value might just be a value that you created inside the function. The return value is just what you will write there. Let me share my screen to give a more explanation on that. I'll share my screen in a bigger way. So this is same class we have been using, and okay. So I'll create a function, function add, no, or function divide. Let's use what we are used to. Now the function divide is A, let's name it A, I32, B, I32, and it returns an I32 value. In this particular case, I want to say if B is equal to 0, inside the block of code, it should panic. Else, it should say A divided by B. I'm sure you have never seen the keyword panic before, and I have not spoken about it. Now, how do I put it? Panic is basically a macro in Rust. And this macro is called when you want to terminate a program. When you want to terminate a program. And in that particular case, you use panic. So whenever your line of code enters some kind of conditions, you use panic to terminate that line of code. But panic is not usually advised to be used at all time because it is important that you handle your code right. Now, going back to what I'm trying to say, it's important that you handle your code by using an error. In this particular case, I should have used a result enum, whereby I make this I32, and then I probably make this string. Then, yeah, I could make this return error cannot be divided. In this case, I'll just use string from cannot be divided. And I would like to ask a question. Can someone tell me, I'm getting back to your answer, but I want to quickly ask this question. Can someone tell me why I'm having an error here? I'm having this compiler error. Can someone tell me why? Yes, Emmanuel.
You did say that when you use the results, that you have to wrap the values in the else with I've forgotten the keyword, but you said you have to wrap it with what's that again?
An OK keyword. Excellent answer.
Yeah, an OK keyword.
Thank you very much. And that's the answer. You have to wrap it with an OK keyword. And so now, that's exactly why it's like this. So now, in this particular situation, answering your question, notice that I can actually add return here. And when I add return, if I save it, I'll add my semicolon and everything works fine. But imagine I do not add the return keyword and I just add semicolon there. It has a problem. But I can add my return keyword here and then everything is fine. And this is exactly how it is done. Me pointing out that you can remove the return keyword, I can even remove it here, is just to make your code lighter. Now, in this particular case, the compiler is not sending any error. It's not sending any error. And that's because I'm not using the return keyword. And in that case, I'm also not using the semicolon. But if I add the semicolon, there is problem. But if I add the return keyword, there is no problem. So that's it. Does that answer your question? Okay, great, great. So going back to the slide. So I have explained this. Yeah, function overloading. What is function overloading? Function overloading is a situation whereby you have two or more functions that have the same name, but they do different things. What then, or how are these functions then, how are these functions identified? Each functions are identified by having what we call different function signatures. What does this mean? This means that a function can have, for the first function, it can have two parameters. Imagine you have a function add, and the function add have two parameters. Now you have another function add, and the function add have three parameters. You have another function add, and that function add have four parameters. In this particular case, those functions are called function overload. This is because the signature of the functions is different. The function signature is different. Now, there are different programming languages that support this. But there are some programming languages like Rust that does not support this. What do I mean? Let's go back to our code. Now, I'll comment this out and I'll create function add A, B. Notice that I did not add the function types in front of it. Yeah, and that's exactly why it is throwing an error. But in this case, I'm going to add I32. And here also, I'm going to add I32. I32. And so it should be fine. Notice that this is also throwing an error. Why is it throwing an error? That's because I have not returned anything. So I'm now going to add A plus B. Now, I'll create another function add. In this time, I'll create A I32, B I32, C I32. Return a tuple, in this case, a tuple of I32, I32, and I32. And what am I returning? I'm returning A, B, and C. In this particular case, why is this throwing an error? This is because Rust programming language does not allow function overloading. That means even though the amount of parameters there or the type of parameters there is completely different, even if the return data type is completely different, as long as the variable name, the function name I mean, is the same thing, it's going to throw an error. Imagine I add 2 here. The function no longer throws an error. It doesn't have a compiler error anymore. That is because the function now have different names. This is add, this one is add2. And that's exactly what function overloading is. Example of programming languages that have function overloading is Solidity. I'm mentioning Solidity because Solidity, this what we are getting at is smart contract, writing the Soroban smart contract. And so I'm trying to explain that, okay, in Solidity, for those that are familiar with writing Solidity smart contracts on the EVM blockchain, in Solidity, you can write a function with different function signatures. That is, a function whereby a function whereby you have two different add, but this AB is different. This one has ABC, and the return type is even completely different. So you can do something like this in Solidity, although obviously the way you write the code is completely different. But you can do the same thing like this. Advantage of doing the same thing like this in languages like Solidity is because it allows you to minimize the use of control flows, whereby a function whereby you need to use so many if else conditions. You might just shorten the function into 2, and making the function 2 means that you are trying to save gas in the case of EVM blockchain. But in Rust, this is not supported in Rust. So when you are writing your Soroban smart contract, that means that you cannot create a function or use function overload when writing your function. So I'll take this out. Back to our slide. Instead of using function overflow, you can make use of different functions, names, or enum. Closures. Closures is another thing we are going to talk about. What is closure? Closure, we are going to talk about it more in the future, but right now we would not be going deep into it. The reason why we are going deep into, we are talking about it at all is due to the fact that closures are also functions. What is closure anyways? They are anonymous functions that capture environment. What does this mean? This means that you might be using certain method. What is a method? A method is basically a function that is added to a class. So a particular function added to a class. Now, when I'm talking about class in Rust, it could be added to a trait, or it could be added to the implementation of a structure. And that is exactly why I do not want to go into that right now. So closures could be used for methods. Methods, imagine talking about methods, you can talk about a vec. Now, if you remember last class, going back to the code, last class when we used this dot push, this dot push is a method on vectors. So this dot push is a function, is an inbuilt function that is associated with the vector. Now, there are different functions that are used in traits and in implementation code that is pertaining to a particular variable type. And in this particular case, push is a method, pop is a method. But then there are other methods that can be used. In this other method, there are situations whereby you use these anonymous functions that are called closures. Example of method you use this is map. When you want to map is a method used for looping in Rust. It might be mapping, it might be map, it might be filter. There are so many functions, so many methods you can use a closures in. And all of these things we are going to see when we are talking about different iterators in Rust. But for now, we are going to keep it simple as to what we are working on right now. Higher order functions. Rust is the type of programming language that allows so many complicated things. And in this case, an higher order function is a type of function that allows you to pass in a function as a parameter. So a function that takes in a function as a parameter is an higher order function. What does this mean? Look at this example. This example function apply. It takes in this parameter function, and then it takes in another normal parameter, which is a normal variable, and an int32 variable, x, and then it returns the i32. In this particular case, the function type must be defined. What does the function type being defined means? As I've always made mention of, Rust is a typed language. So that means that every particular variable you are declaring, every particular parameter you are using, all the types must be known. And that is the same thing with this function. So in this particular case, the function that you are passing in as a parameter in this particular function, the function type must also be known. How do you then declare the function type that you are passing as a parameter? You can declare it in this way by using this keyword where. So I'm going to, in fact, implement this right now here to show what it looks like. So now, let's say you have a function apply, as I've made mention of. Let's still use the same name, apply. And then for that function, the function takes in this, you name it f. Then for the function name, you call the function f, and then you pass in the f. The f is the function type. Then we are going to declare what this f means. In this case, we say the second parameter, we say is an i32. Then we are returning an i32. Now, in this case, we could have stopped here, but we would not stop here. Rather, we would now have to explain what f is. In this case, we use the keyword where. The keyword where, whereby we now say f is what? Fn I32 and this. Then we write our function. In this case, we can now call f and pass in x. Can we see? So in this particular case, we are using a function inside a function as a parameter. So whenever you use this particular function as a function inside parameter, this is how you declare the function type you are using as inside the parameter. So in this particular case, you declare f here, and then you use it here, and then you also use it here. Why are you using it here? It is to ensure that this particular function have an higher order type that is being redeclared. Does anybody have questions from what I've just explained? Are there any questions from what I've just explained? Hello? Any questions? Okay, Coxie.
I'm sorry, can you please explain that higher order function again? I don't really understand. I don't understand why exactly it's needed. Why is it needed?
Okay. Now, there are some particular situations whereby you might need to use a function inside a function. Now, it is based on the architecture of what your code is looking like. But the explanation behind the higher order function means that you can take a whole function. Now, look at this function, add. You can take this full function, add, and then pass it in as a parameter. That is what it means. So this full function, you are passing it in as a parameter inside another function. And to pass it in as a parameter, you have to show the types the function takes in. So this particular function, you have to declare the type it is taking in and the type it is returning. And that is exactly. Now, notice something. If I remove this arrow I32 and I do this, will there be an error? Yes. Why is there an error? Can someone tell me why there's an error here? Can someone explain to me why there's an error here? There's a compiler error after removing the I32. Notice that we are also returning an I32 here. So why should there then be an error here? Can someone tell me why?
Is it because the other function you're calling, you have not specified the return type?
I will take that, but that's not the exact reason. I will take that. I will take that because, okay, someone else have a question. Yes, that's exactly what Coxie said. I would take that. I would also take that because F is not returning I32. I will also take that. But then I would want the answer to be constructed like this. It is because this particular main function is returning an I32, but the variable here that is being returned here is not returning anything. So in that case, it is not exactly because this one is not returning something. In a situation whereby this main apply function is not returning anything, if I remove the return keyword that is returning, if I remove it, notice that the compiler error is gone. So it is mainly because this particular function is returning something. And I have explained it, it is expecting something to be returned. But this particular function that it is taking in, that it is calling here, is not returning anything. And this main function is returning something. It would run a compiler error. But imagine, notice why now let me explain why I said I will not exactly take your answer, but I will take it. But I want you to construct it like this. Notice that this one is not returning anything, right? But then I said I call that function, then I added a semicolon here. Then here I wrote 2. Notice that the compiler error is completely gone, even without this function returning anything. And that's exactly why I said I will not take the answer. It's not necessarily because this one needs to return something. It is because the major higher order function, the apply function, is expecting a return value. And in this particular case, it is expecting a type I32 value. And that is exactly why it is throwing a compiler error. So in the case whereby this particular function that is being called is returning something, that is, it is returning an I32 value, then there's no need to return another one. Rather, we can just add it here. Since we are expecting it to return something, we can add it here. And then we remove this, and then it's also returning a value. Does that make sense? Is there any question on that? Does anyone have any question? Okay, Coxie.
Okay, I think I have 2 questions. Can you go back to the code?
Okay.
Thank you. So, first question is, first of all, you know the way you wrote the function f and apply and what's that called? Lesser than sign and f inside and lesser sign, like close it again. Can you explain what that is doing? Like after the
Okay.
apply, it's like a
Okay,
greater
that's
than
your first.
sign, that's
Good.
the yeah. And the other thing is that I noticed that that curly brackets that you did there, I noticed,
Yeah.
or probably I found out that okay, that's almost like another block of code inside the code.
Yeah.
I don't know if that's true. So is it more of like saying that or like say okay, it's like it's on its own, but it's on its own, like it's just different in a way. I don't know if that's what it means though.
Okay. Let's take your question. Emmanuel, let's hear your question too. So if it's the same question, I can then just explain it at once.
Okay. Yeah. Okay. Please, can you also go back to the code?
Okay.
Okay. Thank you. So, from my understanding of this now, or from what you explained, kind of, right, or what I can sort of infer, it seems like you're doing some sort of wrap around the function that is gotten, and since you like define that the f is a function of I32, which is also returning an I32, that kind of like works because f is also an I32. So the question here is, why is it able to accept that f is an I32 even when it doesn't have a value explicitly defined directly to the function? If that kind of makes sense.
Yeah, your question makes sense. So those are 3 questions. Now, the first question Coxie asked was, why do we have this here? This is because in Rust, whenever you have a completely different variable type that you are reconstructing yourself, you need to add that type in front here. So this F that I wrote here, it doesn't necessarily have to be F. I can change this to G. As long as I change it to G, I must change it everywhere to G. Sorry, to G, to G. Yeah. So it doesn't matter. The point is that you are trying to say, you are trying to say, wherever you see this G, replace it with this. And this expression is an expression to show that this function is taking in a function. And that is why you see fn here. And so this G, that is why you say the keyword is literally explanatory. Where G is fn and it takes in I32 and returns an I32. Now, does that answer your question? The first question, Coxie? Does that answer your first question?
No, wait, not really. Like, are you telling me now that the G itself sorry, it's returning this function you're passing in, because a value from the function you're passing. You know what you're trying to tell me? Like, okay, this is the main function. The main function is the apply, but this apply function is returning that G function. That's why it's in
No,
that bracket.
no, no. What the function apply is returning is this. It
Just
is
one keyword.
returning this I32 keyword,
Okay.
data type. You understand? That is what it is returning. Now, what this G is, let me try to do something. Did you see this? This is
Yeah.
exactly what it would have looked like. You understand? This is exactly what it would have looked like if we were trying to specify that, okay, the function type, the data type for this parameter is a function. This is what it would have looked like. But no, it is not acceptable in Rust. And that is exactly why the function type must be defined by using this where keyword. So it is saying where G is a function, and that particular function is taking an I32 parameter and is returning an I32 value. That is basically what it's saying. And it is saying it, you can basically put it, okay. You can basically, what am I doing? You can basically copy this and paste it here. If this is what is not making it look like you understand, you can basically put it like this. Does this make sense? I understand that talking about this particular type of function, taking in another function, is a completely high-level scope. I understand that. And in fact, so many programming languages does not support this. But Rust is a very advanced programming language, whereby it even have ability for a function to take in another function as a parameter. I understand that. But then this is how you declare it. You declare that it is a parameter, is a function by adding fn, then you declare the function type and the return type of the function, if that particular function has a return type. Does that make sense? And then you declare it in front here as G. In the future, as we go on, just to be sure that, okay, I'm still on the call. In the future, as we go on, we are going to be talking about I didn't get this question. Could higher order function having more than function in param? I didn't get that question. Do you mean could higher order function have more than one function in the parameter? Yes, that is correct. Exactly. Yes, it can basically have. But in this particular situation, that means you would have to add the type of the function. So that means you need to add more of these, where if this one is another function, you can say where this is, let's call this one H. And for H, we say, we name it H actually. You put comma, then you define the H type here. And then in this case, you add the H here. And then you also add the function type of the H at the back here. You do that. That's basically it. Now, going back to your second question, Coxie. Your second question is that the function it is returned. Can you remind me your second question before I go to Emmanuel's question?
Okay, it was about that block of code you wrote, but you have removed it using the curly yeah.
Okay, I have. In fact, I have explained it. So I just brought this one to the next line, and I've made mention of the block of code for a function start from the starting of these curly braces and the ending of the curly braces. So I guess that I've answered your question. Now going to Emmanuel's question. Emmanuel asked if the function type has to be specified and how this function knows the function type that is being specified. In fact, that question answers itself. Emmanuel, am I right? Is that your question?
Okay, not exactly. So,
Okay.
I mean, we know the type, yes, but how is it still able to function without any value? It's kind of like
Okay,
what I mean.
that's your question. That's your
Yes.
question. Good. Now, notice something. This particular function we are calling already knows that the parameter is taken as a function is a function. Then it also knows the parameter that particular function. I had something else. Okay, Levi, I also have a question. Yeah, let's take Emmanuel's question before Levi's question. So this particular function knows the function it is taking in, and it knows the particular type of the parameter of that function, and that is, in this case, it is I32. It also knows the particular return type it is taking out, it is returning, and in this case, it is I32. Now, when that function is called, in this particular case, the function is coming in as a parameter. So you name it function f. This function, we could name it function add. It could be add. In this case, we change this one to add instead of writing f. In this particular case, function add is taking in parameter type I32. And the parameter is taken in, since it is I32, this particular function apply is passing in that parameter is taken in inside the function here. Does that make sense? Does that answer your question? Good. Now coming to Levi. What's your question, Levi?
I think you kind of answered it with Emmanuel's question. I was going to ask like how the higher order function and like the nested function handle like their return types. Like what if they have like different types expected? So like how does it handle that? But I think you answered that.
Exactly.
Right.
And just to demonstrate that answer, imagine we change this one to an F64. What happens? Compiler error. Why are we having this compiler error? That is because the function parameter coming here is expecting an I32 type, but the X we are passing in here is an F64 type. So it's going to return an error. That's because the expected type it is meant to take in is what? An I32. And that basically answers it. I'll return this. Okay. Question from Coxie.
Okay, I don't know if you have also explained this one as well, but you just explained that if it's taking in I32, you have to return I32. Okay, in the situation
No,
whereby
I didn't say if it's taking in I32, it has to return I32. The parameter can be different from the return type, but the parameter of the other function that is taken in as a function must be the same as the parameter it is taking in for that function. So it must be the same. That's what I'm saying. So ask your question.
I think that's it, because my question was related to what you just said. I was wanted to ask if the main function is returning maybe f something, then but the one that is passed in returning like I32 is still going to work.
No, it won't work if the types are completely different. One thing I want everyone to keep in their mind is that compared to other languages, although there are other languages that are typed language, but compared to those typed language, Rust is a very, very typed language. What it means is that if I say what this one is returning is completely different from what it needs to return, it is going to throw a compiler error. And I've explained the difference between a compiler error and a runtime error. A compiler error immediately shows on your code that, Oga, what you are doing is wrong. and you have done some mistake somewhere, and you have to, redeem your mistake. And that's compiler error. So if you use a wrong type for a wrong type, for a different type, it's going to completely tell you, bro, change what you are doing and use a type that I'm expecting. Why is this important? This is important because it helps debugging easy. In fact, I want to say very big thanks to the team of guys that worked on the Rust programming language. It makes work easy because for those that have worked on very, very heavy code base, you'd have written so much line of code, and at the end of the day, your code is just running into bugs. Where is this bug coming from? You don't know that you have used a variable where you are not meant to use the variable type. Imagine doing a concatenation, like I made example of for JavaScript. You use the concatenation whereby you used string, you are adding a string to a variable. Normally, that does not make sense. But JavaScript did not tell you it is wrong. But now imagine you added a string to a variable, and now you are dividing the result by a number with error not true. Imagine you've written so much line of code and you don't exactly know where that particular error is coming from. You now start debugging, console logging all the lines of code, and then so Rust helps you so well. And that is exactly one of the reasons why the Stellar team chose to use Rust as the building block of the Soroban smart contract. So it totally makes sense. It has high speed, it's typed, it has the ability for you to get your compiler error before even running your code. Because all of this code we have written, we have not run it in the console. We are basically seeing the error right on our screen. So that's it. As I started from the beginning of the class, I said that the class will be divided into two parts, whereby we would have our lecture slide, and we would have a situation whereby we have a classwork, and the classwork is being done in the class. And everyone that has problem with this code, you can basically share your screen, and sharing your screen means that you can basically see everyone can basically contribute and learn from your mistake or learn on how we debug your code. But that was not able to happen on this call. And that's because we had so much question fluxing in that we did not even complete our slide for today's class. But I would go back to the slide, and we will in fact complete the slide. And after completing the slide, next class will be different, whereby we take this exercise. Okay, we take this exercise, and in this exercise, the exercise will be done in next class, and it will be the first thing we are doing in the class. And then we are going to do the solution of the exercise together in the class. So continuing it, we've understood higher order functions very well, and we're moving on to comment in Rust. In all programming languages, even in markups like .md files, there are comments, and there are different ways to comment. And in fact, we could say this is not something I'm meant to add to the slide, but it's quite important to add it to the slide. You know why? This is because some of those participating in this class, it's probably the first time they're writing code, and it's important to understand what comment is. Now, going back to our code, you will notice that I commented all of this line of code. What does commenting all of this line of code means? Commenting all of this kind of line of code means that the line of code would be overlooked. So comment is basically used to overlook a particular line of code. And so whenever you comment a line of code, what happens is that when you run the program does not run that line of code. And that's exactly it. To make a comment, you can do the single comment type whereby it's // or you can do the other type whereby you make slash You make star, and then you end it with star and slash. So this is the second type to make comment. But just to be very fast with what I'm doing, I just uncomment everything like this. So that is basically what comment is used for. Importance of comment explains code functionality. Now, as time goes on, we will be writing some certain code whereby we might want to push to Kaggle to, when I say pushing it to crate.io, it means that we are publishing our code, and publishing our code means we want other people to be able to reuse our code. Imagine writing a code whereby all the code does is it does operation. The code is a library for different operations, mod operation, add operation, subtraction, and different operations. Now you want people to be able to use this particular library. You can have comment is basically what, now for this function now, I'm going to uncomment it. I'm going to uncomment this function, and uncommenting it, I can start here and say, this function is used, or I can say it's a generic function that takes in another function. It's basically good for you as a developer. It's basically good for you as a developer to always write comments in your code. This is because you might have seen some memes whereby they're like, shouldn't I me write this code? Am I the one that wrote this code? Because I do not understand what I wrote in the code again. So writing comments in your code helps you understand what you have done in that code. And it helps you, easily come back to a code base you've written for more than 2, 3, 4 years, and you are easily able to grasp on all the things you have done in the code by reading the comments you have added to it. Comment is just basically used to, to add instructions or to add definitions or what a particular line of code or lines of code is used for. And that's exactly what comment is used for. So, example, commenting on complex logic or algorithms. Tuples. I think we've talked about tuples and how to destructure a tuple. So you can reference the Rust book, and the Rust book is basically my major reference to where I get most of the lectures. And why am I telling you this? This is because as a developer, at the end of the day, it is important, in fact, very important, that you understand how to reference materials. Referencing materials is what would help you to look for things that are not even being taught. Because at the end of the day, this programming language is a very wild language. So at the end of the day, it is not 100% of everything in the language that will be taught. So you might have to do personal researches, and personal researches is what you do that would help you to write better codes. So at this point, this is how we come to the end of our class. And one more thing for Cox's question about this that I did not want to talk about, because talking about it is a completely ball game. And that is the fact that adding something like this is for what we call generics. But what is generics? That is part of what we'll be learning in the future. And I would explain more as to situations whereby you don't know the data type that is coming. What do you use in that situation? So until then, does anyone have any question that we are going to discuss? Or does anyone have any comments? The class is open for questions and comments now. Okay. So if no one have questions or comments, okay, Emmanuel. Emmanuel? Hello?
Hello.
Okay, I can hear you now. I can no longer hear Emmanuel.
Okay,
Can
how about
someone
now?
else?
How about now? How about
Okay,
now?
yes, I can hear you now.
Okay, I said I probably joined in late or I missed it somewhat. Compared to other languages like let's say Python, for example, where I can define a class and then I can have functions under that class that kind of inherit, or I could, call functions outside of the class and then inherit the class functions and the functions of the class and use it in different folders and files. So from everything you've shown so far, it's only been functions, functions, functions. So I'm wondering if it is that Rust doesn't have classes. And if Rust doesn't have classes, does that mean that it cannot be called an object-oriented programming language? Or does it mean that due to the fact that it still has functions, it still fits in that category somewhat? That's my question.
Very great question. I would like someone from the audience to give an answer to that question because I have answered that question in the class. Can someone give an answer to that question? Francis? Levi?
Can you please ask the question again? I didn't get it.
His question is the fact that we have been talking about functions since, that other programming languages like Python, JavaScript, that makes use of classes, and these classes is basically object-oriented programming. And we have not spoken about classes in Rust. Does that mean that Rust is not an object-oriented programming language? Is that what it means? So, can anyone say the answer? Cogsy? Okay, I'll give an answer to the question. No, it does not mean that. First of all, I explained that there are different ways of writing code. That is a function pattern, and then an object-oriented pattern, which is using classes, as you've made mention of. But in this case, Rust have much more in that it has the ability for you to use what we call a trait. It also has the ability for you to use what we call an implementation. In Rust, it is called IMPL, implement, but it's basically implementing either a structure or a trait. Now, functions associated to a particular trait or a particular structure can be seen as a class. And this is what we are going to be looking at whenever we get into structs, enums, and other complicated or complex data type. All of these functions are, all of these particular things make it look like a class. Because imagine when you declare a particular struct and you are using the struct as a parameter, as a variable. Once you declare the struct, you can keep on calling all the associated functions to it like a method. And that is basically the idea of a class, whereby you first declare the class constructor, and then once you declare the class constructor, you can keep calling the functions associated to the class. So we can also call Rust an object-oriented programming language because it has the ability to do that. But in some cases, in some languages, for example, JavaScript, you might not need to write the keyword function in front of the function you are defining for you to know that it's a function. You basically does not need to do that. But then in Rust, you need to declare the function names and the function and declare the keyword function while using it in traits or implementation or implementing a struct. So does that answer your question, Emmanuel? Okay, great. So does anyone have any other question? If no one have a question, this is how we would come to the end of our class for today. Thank you everyone for joining, and I hope you have learned a great deal. So we see next week. Enjoy your weekend, everyone. Goodbye. So I'll be ending the recording now. Yeah, see you.